In previous video, we discussed how to develop a Fourier series corresponding to a periodic function by finding the coefficient of a naught, an, and bn. So, getting the coefficient of a naught, an, and bn, it doesn't mean that the Fourier series converge to the periodic function. So, how do we want to make sure that the Fourier series converge to the periodic function? As we know, a function of f is defined in the fundamental interval, which is between negative L to L, and it is periodic with period to L. So at some points in the interval, the function may continuous or the function may have finite discontinuous. So the convergence of a Fourier series must satisfy the Dirichlet condition, where the Fourier series of fx converge to f alpha if x is equals to alpha is a point of finite continuity. And the second one, the Fourier series of fx will converge to 1 over 2 times with the left limit of fx when x approaches a or alpha plus the right limit of fx when x approaches alpha if x equals to alpha is a point of finite discontinuity. So let us see one example from example 6.5a in page 436. So given a periodic function fx is equals to 1 for the interval between negative 1 to 0 and fx is equals to 3 from 0 up to 1. And this function is a periodic function with period QL is equals to 2. So if you notice here, if you can see this graph, this function is continuous over the interval of negative 1 to 1, except at the point of x equals to 0, where this is the point of finite discontinuity. So the Dirichlet conditions are satisfied. Okay, you can refer to other example in example 6.5 to identify what function satisfies the Dirichlet condition. So if the function satisfies the Dirichlet condition, it means that the function can be represented by a convergent Fourier series. But it does not satisfy the Dirichlet condition, so we can say that the Fourier series may or may not converge to fx. Why we can say may or may not? Because there are cases that the functions do not satisfy the Dirichlet condition but still converge to Fourier series. So we can say that the Dirichlet conditions are sufficient, but it is not necessary to ensure that a periodic function has a convergent Fourier series as mentioned.